This is the TYS for the metals chapter. This is November 2002, paper 1, question 12. Which metal can be extracted by heating an ore containing its oxide with carbon? So basically this question is asking you, if let's say I heat calcium oxide and carbon, do I get calcium? Or for B, if I heat iron oxide with carbon, do I get iron? And for magnesium, if I heat magnesium oxide and carbon, do I get magnesium? And of course for potassium, if I heat potassium with carbon, do I get potassium? Okay, metal can be extracted by heating an ore containing its oxide with carbon. So that is basically what this question is asking. Now, if you look at the reactivity series, potassium is the most reactive. Okay, followed by sodium and then calcium, magnesium. Now the top four metals, okay, if you look at page 2 of the Mindmap, you can see that the top four metals, oxides are not reduced by carbon. Okay, the top four. So of all the choices, calcium, magnesium, potassium are among the top four. So the only metal that can be extracted by heating an ore containing its oxide with carbon would be iron. Okay, so this question actually is taken straight out from the Mindmap. Now, why calcium oxide cannot be extracted by heating it with carbon? It is because calcium is very reactive, and hence it has a greater tendency of forming an oxide with the oxygen. Therefore, it is very difficult for the carbon to split the calcium and the oxygen. So it all boils down to the reactivity of the metal. Now, in which tube is hydrogen formed? For the second question. Now, for the second question is November 2002, paper 1, question 14. Which tube is hydrogen formed? Now, zinc and hydrochloric acid. This is actually metal and acid. Metal and acid, what do you get? Metal and acid, again from the Mindmap. Metal and acid, you get salt and hydrogen. So the first question, you get salt plus hydrogen. How about for second question? For the second question is still metal and acid. However, copper does not react with acid. Okay, if you look at the Mindmap again on the first page, copper, no. Over here, copper, no, under reaction with hydrochloric acid. So copper does not react with hydrochloric acid. Iron is the last metal that reacts with hydrochloric acid. All other metals below iron do not react with acid. Hydrochloric acid is very similar to sulfuric acid. So if copper does not react with hydrochloric acid, that means it does not react with sulfuric acid. So this one, there is no reaction. No reaction. How about this? Copper 2 oxide and dilute sulfuric acid. Copper 2 oxide, if you recall, it is a base. So a base and an acid, you get a salt and water. This is from acid and bases chapter. Base and acid, you get salt and water. Now for the third one, for option D, it is zinc carbonate and dilute hydrochloric acid. So this is carbonate and acid, you get salt, you get carbon dioxide, you get water. Again, this is from the acid and bases chapter. Metal, carbonate, and acid, you get salt, carbon dioxide, and water. So the answer for this question would be A, zinc. The next question is from 2003, paper 1, question 12. The metals iron, lead, magnesium, and zinc are each added to dilute hydrochloric acid. Which tube contains magnesium and dilute hydrochloric acid? Among these four metals, you have to arrange them in order of reactivity. So the most reactive is magnesium, followed by zinc, followed by iron, and followed by lead. Okay, this is from the Reactivity Series, page 1 of the Mindmap. So the most reactive metal, which is magnesium, when magnesium reacts with hydrochloric acid, you get, from the previous question, you will get metal and hydrochloric acid, you get salt and hydrogen. Now, since magnesium is the most reactive metal among these four, it would give the most amount of hydrogen, meaning that it would give the most amount of bubbles. So the answer is tube C, because tube C has the most number of bubbles, and the metal in tube C must be magnesium, because magnesium is the most reactive metal among these four metals here. So this would be magnesium, followed by, this one would be zinc, this one will be iron, and lead does not react with hydrochloric acid. Okay, lead does not react with hydrochloric acid. It's from here, lead, hydrochloric acid, no reaction. Okay, the next question. The next question is from 2004, paper 1, question 11. Experiments are carried out to arrange metals X, Y, and Z in order of decreasing reactivity. Okay, the table shows the results. Does the metal liberate hydrogen from dilute hydrochloric acid? Now the meaning of liberate means produce hydrogen from hydrochloric acid. In other words, this sentence here basically says which metal react with hydrochloric acid. So X and Y react, X and Z react, Y does not react. So since only Y does not react, we can say that this Y is the most unreactive metal, most unreactive. So from the first line, we know that Y is the most unreactive metal among these three. Now is to determine X and Z, which one is more reactive. Is the metal oxide reduced by heating with carbon? This question basically say whether or not metal oxide, for example XO, okay, metal oxide, X is a metal, and then XO would be the metal oxide. So metal oxide, it can be reduced with carbon. So this yes here basically means XO, if I heat it with carbon, I will get X. Okay, because the metal oxide can be reduced, so XO can be reduced to X. This one here says that ZO plus carbon, you don't get anything. ZO cannot be reduced by heating with carbon. Now XO can be reduced by carbon, ZO cannot be reduced by carbon. So which metal, X or Z, is more reactive? Now the answer must be Z. Z, this one is more reactive. Why is Z more reactive? Because Z must be more reactive in order for it to hold on to the oxygen and not let the oxygen go away. Okay, so X must be more reactive so that it would bond very strongly with oxygen until a point whereby the carbon cannot strip the oxygen away from ZO. So Z is more reactive than X. So in order of decreasing reactivity would be Z, which is more reactive, followed by X, followed by Y. So it's Z, X, Y. Z, X, Y. So the answer is C. Alright, the answer is C. Z most reactive, followed by X, followed by Y. The next question is from 2005 paper 1, question 11. The results of adding some metals to salt solutions are given below. Okay, so copper zinc sulfate. Now this one is actually a displacement reaction. Magnesium plus zinc sulfate, magnesium sulfate and zinc. Because magnesium is more reactive than zinc, therefore it would displace zinc from the zinc sulfate solution. So the zinc will be left alone and the magnesium will combine with the sulfate. So these are the displacement reactions. What is the order of reactivity of the metals? Now this one actually you don't really need to look at this information given here. If you remember the reactivity series, you can know that the order of metal reactivity here, which is magnesium, zinc, copper and silver. So the answer is B. Let's look at numbers. The next one. The next one is 2006 paper 1, question 11. An experiment is carried out to find the order of reactivity of some metals. 3 metals are placed in separate solutions containing an aqueous metal ion. The results are shown. What is the order of reactivity of the metals? Now similarly for this question, this information is not needed. You can straight away arrange the metals in order of reactivity, which is the first one should be magnesium, followed by aluminium, followed by zinc, followed by iron. So the answer is C. The next question is from 2007 paper 1, question 11. Metal X is more reactive than metal Y, which is more reactive than metal Z. So X more reactive than Y, more reactive than Z. The sulfates of X and Z are colorless. So that means XSO4 as well as ZSO4, both of these are colorless. The sulfate of Y is blue. So Y sulfate, this one is blue. Which observation is correct? Now, Y sulfate is blue. Y sulfate is blue. From QA, you know that this is very likely to be copper 2 sulfate. So this Y, this one could be copper 2 sulfate. So which observation is correct? Metal added to solution of sulfate is X, solution of sulfate is Y. So that means for the first one is X, which is the metal added to the solution of sulfate. The solution of sulfate is Y. So X plus Y SO4, solution of sulfate Y. That means Y sulfate. So if X is added to Y sulfate, the color change would be from blue to colorless. Now first of all, this one is blue. And which one is X and Y, which one is more reactive? So from the question, X is more reactive than Y. So X is more reactive than Y, meaning that if X and Y sulfate is added together, since X is more reactive than Y, so X will displace Y from its sulfate solution, meaning that the Y will be left alone and then the X and the sulfate will join together, will combine. So this is blue, this one is X sulfate, is colorless. So the color change would be from blue to colorless, blue to colorless. So the answer is A. If you look at the second one, Y is added to the solution of sulfate XSO4. X and Y, which one is more reactive? X is more reactive. So there will be no reaction for this. Because X is more reactive, therefore it will hold on to the sulfate to itself. Okay, and you can go through the rest. Okay, the next question is from 208, paper 1, question 14. The diagram shows the reactions of 3 different metals with dilute hydrochloric acid. What are metals W, X, and Y? Now, same thing. It is based on the principle of the amount of bubbles. If the metal is more reactive, it would produce more hydrogen or more gas bubbles in hydrochloric acid. So this one should be the most reactive metal among the 3. So your metal X should be magnesium, your metal Y should be zinc, and your metal Y should be zinc. X should be magnesium. Okay, X should be magnesium, Y should be zinc, W should be copper. So the answer is A. Okay, again, copper and dilute hydrochloric acid do not react. That's why there is no bubble. The next question is from 209, paper 1, question 13. Pieces of copper, iron, and magnesium of the same size and shape are added to dilute hydrochloric acid. The diagram shows the results. Which metal was placed in each test tube? Again, it depends on the amount of bubbles. The more reactive bubble will give the most number, the most reactive metals the most reactive metal would give the most amount of gas bubbles. So this one should be magnesium. Tube 3, magnesium. Tube 2, there is no reaction. It should be copper. And tube 1 would be iron. So the answer is A. Okay, this is from 205, paper 1, question 12. Which statement about the production of iron from hematite is correct? Coke is used to oxidize the slag. So this one is exactly from the page 3 of the mind map. You have to be very, very clear with the reactions here. So the first one, coke is used to oxidize the slag. This is wrong, because the coke, which is carbon, basically combine with the oxygen to form carbon dioxide. Also, it would react with the carbon dioxide to form carbon monoxide. Limestone is used to remove basic impurities. Not really, it's actually calcium oxide. Molten iron floats on slag at the blast furnace. Molten iron and so actually the slag float on the molten iron, not the other way around. And then the hematite is reduced by carbon monoxide. Yes. Okay, the hematite, which is iron 3 oxide plus all the impurities, is reduced by carbon monoxide to form iron. So the answer is D. Number 2. The next question, 2007, paper 1, question 12. Limestone is decomposed to lime in the production of iron in a blast furnace. With which substance does lime react? This is the last chemical equations. The lime react with silica, which is your sand. So it is D. Which of the following explains why recycling ensures that metals will be available in the future? Because there are only limited amounts of metals in Earth's surface. So it is D.